Three classes of electrolytes: acids, bases, salts. The ion of acids and bases. Water can naturally be dissolved into H plus and OH minus ions. When water dissociates, when water separates, it separates as H plus and OH minus ions. One hydrogen atom breaks its bond with oxygen and leaves behind its electron. That hydrogen atom is now positively charged and properly called hydrogen ion, which is H plus. The remaining hydrogen is still connected to the oxygen and which is now has an extra electron, giving this pair a negative charge and is properly called as OH minus or hydroxide ion. If, for some reason, the H plus and OH minus are not balanced, an acid or base is formed. Acids contain excess H plus ions in the form of hydronium ion, which is H3O plus. The bases contain excess hydroxide OH minus ions. The amount of dissociated water molecules in relation to all the water molecules is very small. Since the overall amounts of H plus and OH minus are equal, they cancel each other out, leaving the pure water neither acid or bases, and it is called neutral. What's an acid? The acid of everyday life, the stomach acid, actually dilute hydrochloric acid, which is HCl. Vinegar, actually acetic acid. A common vinegar is 5% acetic acid and 95% water, and it's HC2H3O2. Acetic acid classified as a weak acid since it is citric acid. Some other common acids are listed. Some molecules which are classified as acids in aqueous solution: hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, phosphoric acid, citric acid, acetic acid, and oxalic acid. Some of the acid is any substance whose presence in solution increases the number of H plus ions present in the solutions. The number of H plus ions present determine the strength of the acid. The more H plus ions, the stronger acid it is. The less H plus ions, weaker the acid it is. Strong acid completely dissociates. A weak acid only partially dissociates. Some other properties of acids: acids taste sour, and not all acids are safe to taste. Never taste acid in the science lab. Example: the sour taste of the citrus fruit is caused by the citric acid. Common acids contain hydrogen, that is the ionized aqueous solution. And naming the acids: binary acids composed of two elements, hydrogen and a nonmetal. They are named with the prefix of hydro, the name of the nonmetal, and "ic" as the suffix. Some example is hydrochloric acid. You see that hydro in the beginning, and chlor is the nonmetal name, and then "ic" is the suffix they are used for the acid. Ternary acids composed of three elements: the hydrogen, nonmetal, and the oxygen. The root name is the nonmetal name with the "ic" suffix. Prefix and suffix are used to indicate the amount of oxygen in the acid. Some common acids are hydrochloric acid, nitric acid, and sulfuric acid. Acetic acid is a weak one, and citric acid is a weak one. The other top three ones are the strong acids. Hydrogen is always the first element written in the formula of an acid. What's a base? Base is a substance that generates a hydrogen hydroxide ion, that is OH minus in solution. You might want to think of it as an acid. This is a substance that will react with the acid to produce water, and then when the OH minus ion combines with the hydronium ion in the acid. So whenever this OH minus reacts with this H plus or H3O plus ion, then it just makes the water by neutralizing the acid and base. Base properties. Base produce the hydroxide ion, which is OH minus in the solution. This can be caused by adding OH minus ions or by taking away H plus ions. Bases accept the protons in chemical reaction, and bases are generally slippery in nature. Bases taste a bit bitter. Don't taste bases in the science lab either. The scales of fish are coated with a base that makes them slippery. When you squeeze lemon on your fish before eating it, what you are actually doing is neutralizing the basic bitter taste with an acid, thus making it more palatable, which is a neutralization process. So that's where we are adding the lemon, which is acid, to the bone of a fish, because the fish scales have a base coating on it. So that's why whenever you try to hold the fish, it'll just kind of slip away from your hands because it has that base coating on it. That's the slippery nature. Soaps are also bases and naturally are quite slippery. Your skin is slightly acidic, and acid base myths. Most people naturally think that acids something like harmful. Be advised that bases can be as damaging as the acids, and in some cases even more damaging. The slipperiness makes it hard to wash it off from your eyes. So sometimes when the base gets into the eyes, then it's very hard to wash it off. So we have to use some material to neutralize it and then wash it off. One of the advantages of using bases as cleaners is that they do not react with the metals. So that is why we use all this soap. Those are slippery things, and we use them to wash it with the metal, wash it with the utensils or things like that, because they do not react with metals. The cleaners used to unclog the sinks are strong bases that readily dissolve hair, grease, but they make sure that they do not react with the pipes which are made up of um, metals, and they will make sure that they are remained unscratched. Strong or weak. Whether a base is strong or weak depends on the amount of hydroxide ionized. And naming the bases. Almost all the bases are composed of a metal and a hydroxide ion. So they name the metal first, then the word hydroxide. So some of the examples like sodium hydroxide, calcium hydroxide, magnesium hydroxide, ammonium hydroxide. As you can see that the metal goes first and then the hydroxide as the second word. So this is how we name the bases. Characterizing the acids and bases, the pH scale is used to express the degree of acidity or basicity, and the range of the scale is from 0 to 14. 7 is the neutral point, the pH of pure water. pH below 7 is acidic, and above 7 is basic. So which is from 0 to 6 is the acidic, and 8 to 14 is basic. The pH scale, it is important that the scale is logarithmic. So the change of 1 is 10 times more than the earlier scale. So meaning of log scale is if let's say that a pH scale is of 2 is twice as acidic. It is a pH of 2 is not twice as acidic as 4, but it is 100 times as acidic. And pH of 2 is not 3 times as the pH scale of 6, but rather 10,000 times as acidic. Thus, the scale represents a wide range of values. You can see that pure water is at the neutral, and milk, coffee, tomatoes, and all these sour things are classified into acidic. And as it grows in this direction, it is much acidic. And you can see that from here to the 14, it is basic. pH scale summary: a neutral solution has a pH of exactly 7 and it contains the hydronium and hydroxide ions equal number. Pure water dissociates into hydronium ion and hydroxide ion. And an acid solution has a pH lower than 7. It contains more hydronium ions than the hydroxide ions. The farther from 7 it is, the stronger the acidity. So from 7 to 0, the acidity gets stronger and stronger. The basic solution has a pH of pH higher than 7 and it contains more hydroxide ions than the hydronium ions. Farther from 7 it is, the stronger the base it is. Mixing an acid with base. A chemical reaction occurs when acid is combined with base. The hydronium ions in the acid combine with the hydroxide ions in the base to reduce the total number of ions in the solution. The overall result is a neutralization. The product of the neutralization is a water and a salt. Preparing a salt. A salt can be obtained by mixing a correct combination of acid and base. After neutralization, the salt will be in the solution with water. Allowing the water to evaporate will leave the dried crystalline salt. Chapter 11 summary is crystalline solids have particles arranged with long range order. Amorphous solids are randomly arranged. There are 4 types of crystals. Uh, Crystalline materials, which is ionic covalent, and they are formed by these. Metallic bond is sea of electrons. Van der Waals force from Van der Waals forces stem from electrical attraction. Solution is 2 parts solvent and solute. Solubility is a measure of the amount of solvent then it can be dissolved by a solvent. Saturated solution has the maximum amount of solute. Polar molecules have spatially separated charge, and polar liquid solvents can only dissolve ionic and polar covalent compounds. Nonpolar liquids dissolve only nonpolar covalent compounds. Ionic compounds dissociate in an electrolyte. Acid contain H plus ions and bases contain OH minus ions. And pH is the measure of acidity and basicity of a substance. Acid-base neutralization forms water and salts.